Hello, everybody. You do know that James Gosling's in the other room, right? Seriously, it's lovely to see so many people here, old friends and some new faces as well. For folks who have not met me before, my name is Ben Evans, he, him pronouns, and I work at Red Hat, where I'm a senior principal software engineer and in charge of observability for Red Hat Runtimes. But that's not what I'm going to talk about today. Instead, I'm going to take a sort of chance to do a look back and a retrospective over 10 years of the well-grounded Java developer, which is actually the first book that I ever wrote. Hands up if you've read the book, either the first or the second edition. Okay, about half the room. Okay, that's cool. Thank you. So prior to being at Red Hat and working with observability, I've done a bunch of other things. I was lead architect for instrumentation at New Relic. I founded a company called jClarity, which we'll have a bit more to say about a bit later, which was acquired by Microsoft in 2019. And before that, I spent a bunch of time working in finance, Deutsche Bank, Morgan Stanley, where I actually was the performance engineer who was responsible for testing the Google IPO. So, I've just remembered I have a missing slide. Because I work for Red Hat these days, and Red Hat is a publicly traded company, there should, of course, be a safe harbor slide. Now, you can kind of imagine that here is the Emperor's new safe harbor slide, and on it, it says that nothing I should say should be used as the basis of any kind of purchasing decision you might or might not make. Unless, of course, it's to buy me a beer in the bar later to find out some of the stories and where the bodies are buried about some of the companies that are listed on the board here. Okay? So in addition to my sort of professional life and all the places I've worked, I've also been deeply involved in the Java community. So this really is a sort of a personal retrospective about a bunch of things. I'm a Java champion. I've spent many years living in London. I live in sunny Barcelona these days, but when I was living in London for almost 20 years, I spent a lot of time working with, as part of the organising committee for the London Java community, serving on the Java Community Process Executive Committee, and helping to found a little project that you might have heard of called Adopt Open JDK. These days, of course, that's known as Eclipse Adoptium. Again, just because I'm curious, how many people run Adopt Open JDK or Adoptium now in production? Okay, about a third of the room. That's cool. Cool, all right, so that's enough about me. Well, and let's talk about what we're actually going to talk about today. So I'm going to explain basically a bit about where the book came from, where this entire concept of being well-grounded, the well-grounded Java developer, where it all comes from. And, you know, to then talk about the first edition in context, because it was quite a long time ago now, but there are some, I think there are some interesting points that you might not have thought of that we'll go through as we talk about the first edition. Then, of course, we'll talk about how the world has changed, the new second edition, which came out last year. And then I want to kind of pull all those threads together and look a little bit into the future and think about what has changed, where the continuities are, and what new things are coming, what interesting things are happening for us as developers, and if we want to stay fresh and well-grounded. Okay, so let's start with a kind of a brief history of the book, if you like, and then we'll talk about the term well-grounded, and then I'll explain the entire point of it, what we did when we came up with the idea in the first place. So we rewind all the way back to 2009, and I just joined Deutsche Bank, and I got through the door, and they said, "How was onboarding? How are our training materials?" And I said, "Meh." And they said, "Oh, good. We hoped you'd say that because fixing them is now your job." So my first task was to fix the training materials for new hires. And after a couple of weeks of this, I was really pretty grumpy and upset about it because I'm like, there should be a book. There should be something that I can give to my new hires as they come in so that they can actually learn the things that I need them to be productive. Hold that thought. It's going to be important in a second. And so given that I was feeling somewhat unhappy and disgruntled, my boss said, you need a break. Why don't you pick a conference and go to one? And I said, okay, well, I've heard good things about DevOps. It's like, okay, sure, go to DevOps. Put your expense claim in. So I came here 14 years ago, and it was actually out here on this top thing, the top landing, where the next step happened. I was chatting to Holly Cummins, who I think some of you know, and she says, oh, by the way, there is this unconference happening in London in a few weeks' time. you should come to that. It's being organised by the London Java community. You might meet some interesting folks and see some good talks. So I did. I went along to the unconference a few weeks later, and I met Martijn. He can't be here today, unfortunately, because he lives in New Zealand these days. But we met up, we decided to collaborate, and then something unexpected and really rather nice happened, which is that Deutsche Bank gave us the copyright of all the material that I'd been writing as working on as training materials. And so to take out all the bits which refer to Deutsche Bank proprietary technology, and we will give you the rest. Something they didn't have to do, a very, very unexpected and very nice surprise. And so that was the sort of the core of the book that Martijn and I started working on. And we worked on it fairly intensively, I think, over the next sort of 6 months. And by the time it got around sort of April, May time, we actually felt like we had something to do, that was taking shape, that we had something which could be perhaps even turned into a proposal. So we duly did that, and we started thinking about publishers, and there were a few on the short list. And the first one we approached, Manning, said yes almost straight away. So we're like, oh, well, that was surprisingly easy. So what about this concept of being well-grounded? Well, it's at the heart of everything that's in the book. And I think it really kind of, for me, it's similar to an analogy that you might have heard of. You might have heard this before, but sometimes people say that software is a combination of working down from the glass, i.e. starting with the user interface and the user experience and going down deeper into the systems, but equally it's also about working up from the silicon, starting with the hardware, moving up through the operating system and the different levels of the stack. And this idea that you have to combine those levels of thinking and the different pieces and being able to switch between them or hold both in your head at the same time, I think is an incredibly key skill, especially as you get to be more senior and more advanced. So people like technical architects, staff engineers, this is one of the key differentiating skills, I think, that when I'm looking for people who are going to fit into that role. So a similar concept in Java, and where the start of the concept of being well-grounded is, where it comes from, is that there is a duality when working in Java between a surface of an API, how to use it, being a consumer of an API, and to understand how it works, to understand the basic pieces of the platform and how to use them to build up these abstractions. For people who were in Brian Getz's talk just prior to this one, Brian talks about the dynamism and the annotation and the reflection, which makes things appear to be magic. Automatic wiring via annotations, package scanning, class loading, all the stuff that's in the JVM. To a beginning developer, it can look just like magic, but I promise you that it's not. And you can all build something similar yourself. It may not be fully featured, it may not be production quality, etc., but you could certainly build it. And if you haven't done that, there's actually an example in the book where you can build a simple JUnit runner, find things with a test annotation, and run them. And just doing those exercises a couple of times is incredibly powerful. It extends your knowledge. And this really is, I guess, the overall goal of the book. We want to take intermediate Java developers, people who are already familiar with Java, the language, and level them up. This is not a first book about Java. It is not, Java in a nutshell. It's not headfirst Java, if Trish is here. It's something about leveling you up. Something about, if you imagine a pyramid of developers. So you've got people at the bottom who are really kind of basic and just very new to the profession. And then you've got this sort of layer of intermediates. And then you've kind of got a top tier. A lot of our audience is about people who are in this sort of middle tier and would very much like to push upwards, to maybe get into the top tier or get closer to it anyway. And so that is the idea, that is the concept of what being well-grounded means. It means having the context to see at multiple levels and the desire to use platform techniques to push yourself a little further. Okay, so this brings us to the shiny blue first edition, which I'm quite surprised is still A, available on Amazon, and B, every month or two, some poor soul buys a copy of it, which it's fine, but it is well over 10 years old now, and there is a big banner at the top of the Amazon page which says, click here for the second edition. But for some reason, people still want to buy the first edition. Very few of them. Don't know why. Maybe it's, it's possible, I suppose, that it's actually some sort of bot that's gaming the Amazon page, but I can't imagine what the benefit of that would be. Anyway, so let's talk about this. Where were we in time at this point? What was happening? What was the moment in history? Well, if I want to give the briefest history of Java I possibly can, it starts like this. Sun released Java in beta in 1995, and at that time there was a language called LiveScript, which had been developed by Netscape and was in the original Netscape browser. And for reasons purely to do with marketing and mindshare, they decided they would change the name from LiveScript to JavaScript. Yeah, sure, you could use LiveScript to activate and manipulate and interact with a Java applet. Sure, but you could do a bunch of other things with it as well. So it's purely marketing. If you've ever wondered why it is that Java and JavaScript have such similar names despite appearing to have nothing at all in common with each other, there we are. A bunch of other things happened, 5 more releases of Java follow, and we fully fast forward to 2006. Something which is perhaps more significant than it first appears is the final and complete open sourcing of Java. Bits and pieces had been open sourced before, but it had never really been a full open source package. Okay, so what happens next? Well, enter Oracle. So Sun basically it ran out of money after the dot-com crash. I mean, that's really the simplest way to explain it. And so in 2010, just as I was starting to come to DevOps and met Martin and we were working on the book, Oracle acquire Sun. Okay, and at that time, Java 7 had been this release of Java that it was kind of like, have people heard of the paper tiger anti-pattern? Well, maybe not by that name, but what it is it's a system which is intended to come in the future, and people think, oh, well, it's going to be so much better than what we have now, but because it doesn't have a defined release date, because it doesn't have a plan to get there, the release date keeps slipping, features keep getting added to it, because, oh, yeah, it's the shiny new system. It's not here yet. We've got plenty of time. Let's add more features. Let's add scope to it. And so, of course, it balloons and it never actually arrives. And that is basically what had happened to Java 7. Java 6 had been out for quite a few years. Java 7 never seemed to be delivered. So one of the first things that Oracle did when they acquired Sun was they basically, Mark Reinhold, put out a question to the community. Do you want Plan A, which is to push on with the release of Java and with all its super features, lambdas and what have you, or do you want us to cut it into 2 releases? We'll get you what is productionizable as quickly as we can, and then the rest of it, which will definitely include lambdas and modules, as part of Java 8. Okay, so sure enough, the community heavily votes to say, look, let's cut it into 2 pieces, give us what you've got now. So that's why very quickly after Oracle acquired Sun that we actually get Java 7. And it's this world that the well-grounded Java developer was born into. There are some complexities around how the open sourcing and the timelines work. Because when Sun announced the open sourcing of Java, they didn't really have a code base that was ready to be open sourced. So as a result, there is something called OpenJDK 6, but it never really corresponds to any defined Java 6 that Sun released. Okay? So the point at which Oracle acquires Sun, OpenJDK 7 is already in flight. So Java 7 and onwards are essentially entirely equivalent to Oracle's JDK. I included this slide because I still find people that don't know that. I encounter people very occasionally in the Java community who still think that there are material differences in JIT compilers or garbage collectors or things like that between OpenJDK and what Oracle releases. There is absolutely not. Not in OpenJDK. GraalVM is a different story, but we're talking about OpenJDK here. So okay, so what was in our first edition? Well, remember the whole point here is to kind of level up. So sure, Java 7, it's the new kid on the block. There are some interesting, cool new features in it, kind of. But the other thing which was also, I think, true in those days, and I think looking back, people probably don't realize or don't remember just how unusual things like dependency injection really were back then. Spring's not widespread. Dependency injection was a kind of a novel concept to a lot of Java developers. Things like class files and bytecode weren't really talked about much either. Test and build and CI. Yeah, I shudder to think how many code bases I looked at in those sort of days where it just didn't have any test cases. Like the virtue of having, automated tests was still not embedded in many, many development shops. So there was this sort of strange feeling around some of these features, and so we put them into the book in order to try to help do our bit to get them into the wider developer community. So what was in Java 7? Well, a bunch of things. Project Coin, which is basically diamond syntax, and a couple of other bits. NIO2, which is basically the path API, which obviously then develops with files. The nice API that we like for doing Java I/O. Try with resources. Yeah, it seems strange now, but one time we didn't have that. And then the last two, which are really the two I want to kind of focus on. First of all, is G1 as preview. And I was using G1 since the 7 betas, back when it used to reliably crash about 20 minutes after you turned it on. And it sort of represents, I guess, a point in time, a view of the difference between the parallel collector, which of course is very throughput orientated and is good, but has bad behavior. Well, not bad behavior. The pause times scale linearly with the heap size. So the bigger your heaps get, the longer your G1 your parallel collections are likely to take. So this was a glimmer of what would eventually arrive in later versions of Java 8 and eventually and turn up in Java 9. So it's an interesting start of the journey, the thread which leads us to modern thoughts about GC. Okay, and then finally, the surprising one, Invoke Dynamic. Invoke Dynamic was the first bytecode that had ever been added to the set since Java 1.0. Never been added before, and to this day, to Java 21, no other new bytecodes have ever been added. It's possible some might have to be added for Valhalla, but we just don't know yet. So Invoke Dynamic is kind of a strange thing. What it basically does is it's the extreme end of the dynamic features that Brian was talking about. It means that you can have methods that you don't need to know about at compile time, or really right up until you try to execute the method call. And over time, it's evolved to get faster and faster. The surprising thing about it is, well, there is no Java syntax which enables you to say, I'm going to make a dynamic call here. It just doesn't have any syntax. It didn't have it in Java 7, and it didn't have it in Java 21. And in fact, in Java 7, there was nothing you could do, literally nothing, to get the Java compiler, Javac, to invoke dynamic. It would not do it. So it's kind of a strange thing, because as we'll see, it got kind of important. Invoke dynamic is at the heart of so much of what is dynamic about modern Java, and yet it shows up in this little humble, almost insignificant way. And I suppose you can also argue that the diamond syntax is the first time that Java really starts to think about type inferencing. And obviously that becomes a major thread in modern Java as well. So I just like to pick out these features and just show you, because this is one of the things of the years I've been working with Java, that there are these threads, there are these places where things start. Great oaks grow from tiny acorns. Okay, so that was then. Now let's bring us up to date and talk about how the world has changed. So I think it's kind of fun to talk about what we predicted, what we got right, and what we got wrong, and some things which just came completely out of nowhere. Because it's always good to do a little bit of a retrospective. So in case everyone's forgotten, here are our milestones after 7. 8 was retrospectively deemed long-term support release. Yeah, I know Brian has got his own opinions about this, but hands up if you run a non-LTS version of Java in production. One hand. Well, yeah, I don't either. So here are our LTS releases, and I've kind of skipped the feature releases. I mean, they play a good part. I do, of course, develop and test against them, but just don't run in production with them. Okay, so this basically gives us 4 releases. So what were we able to predict? Well, lambdas, functional programming, GC evolution. These are the sort of big 4 things that we sort of bet our as being the things that we're expecting to see in the future when we wrote the book. Now, lambdas were really not hard to predict. They were already being very actively discussed. There were a bunch of different viewpoints as how to do lambdas. And the point of Project Lambda was really, and this is one of the things I thought was absolutely brilliant about it, to focus on high-level goals. Rather than think about implementation details, think about what you actually want to do. Think about how, the design aspects of the feature much more than the implementation. And this, again, is a consistent principle. We see this all the time in the Java space. That's what the language design folks really like to try and do, is to try to get us up to the level of think about the feature rather than the details of it. What was also interesting was how it evolved to realize that introducing lambdas, sure, yeah, we can do that, but what else needs to go along with them? So you end up with things like default methods, the core libraries needing to be upgraded, and of course streams, which I'll come back to. Okay, so what's the result of all of this? What were the design goals for lambdas? Well, I think they're these 5 things here. It's all about expressive programming and better libraries and improved safety, right? These are very high-level concerns, right? We're not talking about are they just compiler-derived inner classes or anything down at that level. We're way up in the design space here. And I would say that, pretty much these were achieved, with the exception of data parallelism. The hope that you could just automatically parallelize streams turns out to not be realized in practice. Yeah. Oh well, these things happen. Not every design goes the way that you think it will or you hope it will at the time. But to have achieved the first 4, I think, is really pretty stunning. And also, just while we're here, because I mentioned it earlier, invoke dynamic. Despite what you might think, lambdas are not inner classes in disguise. Did anybody think that? Hands up? Yeah, a few people did think that. Yeah, good. That's why I put the slide in. They're not. There's invoke dynamic magic. If you haven't used the Java P tool, write a simple class with a lambda in it and Java P it. And what you'll find is that your lambda body is turned into a hidden private static method that you didn't know about. And instead, there is some magic runtime linkage with invoke dynamic, which happens to make it all work. One of the reasons for this is this enables you to change the implementation. As long as you're carrying around the piece of code, the body of the lambda, and you've got it stashed in a private method somewhere, how it actually gets linked and how you cache it and all of the runtime dynamic stuff can be changed without anyone having to recompile their code. Because that part is determined at runtime. And that has actually happened. The Lambda implementation is different between the early versions of Java 8 and the later ones. But that doesn't need to concern anyone because it's purely a runtime-based aspect of it. This type of thing is what makes the dynamism of the platform really, really attractive. That you don't get stuck with outmoded, pre-compiled code that it won't get any faster until you recompile it. Later releases of the JVM pretty much always improve performance. So you can get a boost by just coming to the latest version of the JDK without having to do anything at all else to your code, not recompiling it, not repackaging it, nothing. Just flip the switch, upgrade the version, you get better performance. One other thing I did want to mention here, which is sort of a note of caution, a slight weakness, if you like, of Java as well, is that we depend on backwards compatibility so much. Now that's good and bad. It's good because, well, people know that they can trust that Java's not going to break stuff unnecessarily. So you can invest in it. You can set up Java teams and do projects in Java and know that things aren't going to change underneath you. The problem is you end up carrying a lot of baggage. And in the case of streams, this is a problem because the collections are first class. They are embedded in the signatures of methods throughout the JDK, and streams are not. So you can't really get around the fact that streams are a bolted-on abstraction. They're not part of the libraries in the same way that they would be in other languages. And unless you're going to give up complete compatibility with the collections and have an alternate collections library, then you're kind of stuck with it. There are some other things wrong with them as well. For example, there's no, if anyone's written any Scala, Scala's got a concept called a traversable, which Java just doesn't have. I don't really know why. And if I say functional collections with bunny ears, I think some people might, functional containers with bunny ears, I think some people might know what I'm referring to there. But I'm not going to get into that. Okay, so that was some of the stuff that went into 8. We also thought about concurrency, and this is an interesting one. I think we got this one mostly right. One of the things that I refer to a couple of times in the first edition is what's called runtime managed concurrency. This is things like fork and join, common thread pools, async I/O, which is present in Java 7 in a very small way. There's a kind of a callback style which you can do, and there's also some future-based I/O which you can do as async. And we were pretty sure that this was a trend that was going to continue, and we did reasonably well. We didn't quite predict vthreads, and I think we probably thought that async await was going to be the direction that Java would take, and of course we now know that that's not the case. But we also picked up on the thing that in order to increase density and deal with multi-core machines, concurrency was going to need to be a thing. It wasn't many years before that multiprocessor machines were actually quite a rarity. And that is one of the things that has fundamentally changed. I very much doubt that any of us will ever program on a single processor machine again. Well, maybe some people that like messing with embedded stuff, but even there, increasingly those chips have multi-core as well. And evolution of GC. Yeah, and this one was pretty obvious as well, because, well, parallel is order n in heap size. So if you have a 20 gigabyte heap, when that does a full collection, you are having a bad time. We had CMS, which was a concurrent collector, but it had noted drawbacks, all kinds of things. And so G1 is really an attempt to do both. And it actually does pretty well. It took longer to stabilize than perhaps I was expecting. I was very surprised when they made it the default in 9, because I didn't think it was ready. But by the time Java 11 rolls around, the version of G1 which is in Java 11 is really good. And it's got better over time as well. So I think it's a huge success. We also have, of course, Shenandoah and ZGC for large heaps that still need low latency. Okay? One thing I want to say about this, because, again, I think there's misconceptions about it. Shenandoah and ZGC will take very large heaps, but unless you have tens or hundreds of gigabyte-sized heaps, they won't do very much for you over what G1 will do. And it's really the 100 gigabyte heap that still needs to know that the GC latency will be sub 5 milliseconds, right? That's the use case for Shenandoah and ZGC. And remember, everything is a trade-off. You don't get that for free. You are going to pay a significant computation penalty to get it, like 15%. So, of course, in the modern world of cloud, that translates directly into higher infrastructure costs because you need larger clusters because your throughput's dropped. So these things are not easy trade-offs a lot of the time. Okay, so what did we get wrong? It's always fun to talk about when we get things wrong. The two things I think that we most got wrong were modules. Yeah. I really had high hopes for modules. I thought they were going to be revolutionary. I thought they were going to really reinvigorate things and try to solve problems with the architecting of large Java apps. And in some ways, they still are a great idea, but there are two problems, which are kind of really connected. Yes, modules within the JDK are one thing, but packaging your code in your applications is quite another. Who does routinely package their code as modules? Hands up. Yeah, that's about what I thought, like 2 or 3 people. If you can get it done, it really does help. But the two things about it are, for existing applications, I don't like the word legacy, but existing applications which are running in production, moving to modules can be a huge pain. And quite often, there are better places to spend your tech debt budget. Modules often just get shunted down the priority list because there are so many other things to think about. Secondly, and related, is that they are a boil the ocean problem. You can't really get the full benefits of modularization until all your dependencies are modularized and all their dependencies and so on and so on. The whole transitive graph of dependencies has to be modularized before you get the full benefit of it. So I'm not surprised that progress has been slow. I think it probably could have been a bit faster, but we are where we are. Anyway, have a think about modules for your next greenfield application, even if you can't get your old applications upgraded. And secondly, HTTP2. I really hoped that this was going to be a really good way to fix some part of the JDK that was really suffering and has really not been upgraded much since Java 1.1 or so. And unfortunately, it's not happened. You know, if you've worked at a low level with the HTTP client classes, you know that there are missing things. There are things that you just have to add in, you know, every time you work with them. And the API is just not complete enough for very serious work. And it's also failed to keep up with things like gRPC as well. So yeah, I think those were our two biggest things that we were probably too over-optimistic about. Okay, what else? Well, there's some things we totally missed. I don't think either Martijn or myself really thought about containers or Kubernetes, and we certainly didn't talk about or think about AI and LLMs in the way that we perhaps we might have done. But I'll talk about both of those later on. The one that I definitely have to own is observability, because we were running jClarity at the time, and we kind of should have potentially seen this one coming a bit better. Our approach to the world was really about single JVM performance. We missed the wider significance of needing to analyze entire systems, clusters, and so on. I have learnt my lesson, and so if you want to hear essentially my current thinking about what observability looks like for Java developers these days, there's a link there. So that's the open telemetry space, which I think is probably the most exciting part of observability right now. Okay, so that brings us kind of to a decent post-mortem on the first edition. So enter the second edition. So yeah, this is kind of an interesting story. I had hoped that I was going to be able to bring a copy of the first edition and the second edition with me, because if I did, I could hold them up and I could say, well, the first edition's about that thick, and the second edition's like that thick, because this was my lockdown book. We started writing this during COVID, and the time was right to do a second edition. And we wrote and we wrote and we wrote, and lockdown finished, and I was living in Barcelona. I started to see my friends going out and having beer on terraces again, and I'm thinking, and I'm in here writing. Isn't this thing done yet? And then I realized that all the time that I've been writing, sure, more words were getting added, but the book wasn't getting any more finished. So at that point, we're like, right, okay, we're going to stop adding topics. We're just going to hunker down and finish the thing. So we did. So we were joined by our friend Jason Clark, who is working with Relic, and we basically decided that we were going to refocus things a little bit. Obviously, yes, update to Java 17. We wanted to change the languages, because the other part of the well-grounded Java developer is that knowing more than one language makes you a better programmer. And it's not even. You know, if you know both Java and C#, you get a little bit of benefit, but they're fundamentally really very similar languages. And you're not going to learn a great deal about programming if those are the two languages you know. You know, you'll learn more if it's Java and JavaScript. You know, but the more different languages and the more different types of languages you have, the better a better programmer you become. Because it's not just about programming in those languages. The techniques and the styles and the deep structure that you see in another language, you can bring back. So your Java code may look different because it may have brought in some techniques from another language which you wouldn't otherwise have thought of. So I've always been a big fan of multi-language. So we decided to shift the emphasis, and the original languages were Groovy, Scala, and Clojure. And we decided that actually we were going to drop Scala and Groovy and just focus on two languages apart from Java, Kotlin and keep Clojure. So why did we do that? Well, in Java 7, there were no lambdas. If you wanted to do anything which looked like a lambda, you wrote a tiny little inner class. And so many dev teams just kind of wanted lambdas and a sort of better Java. And Scala and Groovy both filled that role. Scala had first-class lambdas. It had type inferencing, and that's really what a lot of people wanted. Groovy had dynamic typing, which sort of gave you some of the same benefits as well. Over time, though, things changed. Groovy's advantages kind of withered on the vine a bit. A lot of Scala folks went down the rabbit hole of formal functional programming, or FP. Some people describe Scala these days as kind of Haskell on the JVM, which is probably a little unfair, but there's certainly some truth in that. Does anybody actually program in Scala these days? Hands up. No Scala programmers. Okay, interesting. But what that meant was that for folks who wanted a better Java, well, they went in one of two directions. They either came back to Java as features got added, or they went to Kotlin. So we felt that basically by getting rid of Groovy and Scala and replacing them both with Kotlin, we could do a better job of it. We did originally also think about, well, let's just get rid of Groovy and put Kotlin in. But then I started looking at the code samples, and I realized that we're not doing deep Scala. So at a basic level, Kotlin and Scala syntax looks pretty similar. So it felt like it would be overly repetitive. So we, in the end, made the decision to drop Scala as well. Okay, so why Clojure? Well, Clojure is a very different sort of functional programming to Scala. It might be the case that Scala feels dynamic, but it's actually statically typed. Well, Clojure is dynamically typed, definitely. It feels like an interpreted language. If you've written any Clojure, you'll know what I mean. But it's compiled. And this is a standard thing which happens with Lisps. One of the major design points of a Lisp is that it should have a very simple compiler. And so it's that aspect of Clojure which makes it feel like an interpreted language and instead be a compiled one. Of course, it has functions as first class. That's table stakes for a functional language. It uses what's called the binding model for data rather than the mutable storage model. If you're an imperative programmer, Java, C, C++, whatever, your picture of memory is it's a box. It's a box. You put thing in box. You take thing out of box. You put different thing in box. It's mutable storage. That's not the way that Lisps and other languages which have that feature think about data. If you want to know more about it, it's in the book. And the other thing which I really liked about Clojure was just how different the approach for concurrency was. And I actually strongly feel that Clojure's software transactional memory and persistent data structures are really very, very beautiful. Okay, so what else? I mean, yeah, I think a lot of people have the wrong idea about functional programming. They think that first-class functions are all it takes to make your language functional. That's not really true. Functional programming is a sliding scale, and your language can sit pretty much anywhere on it. And the more of these that you have, the more functional you are. You might want to take a second to have a look at that list and think about how many of those Java has. Oh, some, kinda, but certainly not everything. So we wanted to focus on fundamentals. So we had some topics from the first edition that we updated: class files, concurrency, performance, all of that. Dependency injection is now so widely known, there's really no need to talk about it anymore. So we just dropped that. We changed the focus of build and test, so that now we're talking about building with Gradle, with Kotlin rather than Groovy. And to push the frontiers of testing. That is one of the areas I think which really has changed in the last 10 years. Unit testing is now ubiquitous. I can't remember the last time. No, I can remember the last time I saw a code base without test cases. It was 5 years ago, and they had to pay me danger money to go near it. But what that has meant is that we now have new horizons in testing. There are things like test containers. There are more types of system and component level testing which can be done, but which aren't always widely thought about. And then, of course, the cloud and deployment has become an increasingly big subject. So we added some sections on that and some more stuff about the frontiers. Okay, so that's where we landed with the second edition. So what's ahead? Let's start to pull these threads together to think about future Java, more concurrency, more functional programming, more JVM, more cloud. These are the things which you're going to need to stay well-rounded in the coming years. And the concurrency and functional programming threads, I'm prepared to stand here now and say these are things which are going to be important and continue to be important for the next 5 to 10 years at least. So to return to an earlier idea, Java is now adding language features rapidly. You know, the 6 months cadence, the iterations of that work well. They do. I mean, we might not put anything but LTS in production, but the new language features are actually helpful, and they do show up with great regularity now. It's also the case that we have better developer productivity too, and that again is a side effect of the 6 monthly model. So increasingly, if you want a better Java, the answer's Java. There aren't many features, if I look back a few years, that we're not starting to get in Java now. And that has a couple of knock-on effects. One of which is that it's harder to see any non-JVM language go completely mainstream. Kotlin, because of Android, is a slightly special case, but apart from that, nothing new that came up can I see, you know, displacing Java, even in part. But you know, for some use cases, and just because it makes you a better programmer, you should know a non-Java language or two. If you like functional programming, or you just like Lisp, or you want to see something which is done completely differently, have a look at Clojure. If you need to develop Android applications, or you just want a change of pace, then Kotlin is a fine language as well. So what is not going to change about Java? Well, Java has a set of design principles or design goals which you know I think are fairly obvious once you think about them. Firstly, around the type system. This is how I would describe Java's type system if somebody asked me. It is statically typed. It is nominal in the sense that types have names. There aren't types which have some other criteria to determine them. It's an object or an imperative language, if you like. It's type erased in its generics. It's modestly type inferred, and it's slightly functional. So those are the criteria for, or the words that I would use to describe it. Notice it's static typing. It's very much not strong typing. There is no such thing as strong typing. It does not exist. All that the phrase strong typing indicates is the person speaking likes the type system that's being discussed. Apart from that, it has no outside or objective meaning whatsoever. This type system, of course, is the class file is the basis of the static type system, and I think one of the things that we've learned over the last 20 years is that lots of people love the freedom of dynamic typing, and then rediscover why we had static typing in the first place. It's part of the nature of software. It can be fashions, trends, I don't know. The pendulum swings one way and then it swings back the other again a few years later. But static typing, I think, is very much here to stay. Types are nominal. They're only compatible if an explicit inheritance relationship exists. There is no way of talking about a type by name, and there's really no duck typing in the Python sense at all. We have a very simple OO model. It's not pure OO, which actually is part of the problem. That's one of the things which Valhalla tries to solve. And this is effectively what's the word? A vestigial, a leftover piece of design from the mid-90s. Java is not a single-rooted type system. It's not an everything is an object language. Why? Well, because in the late 90s, where it came from, that was too expensive in terms of runtime performance. So we have primitives in Java because they go all the way back to needing to do things faster and not giving up complete performance. And it also made it easier to talk about it to C and C++ developers, who were the original primary audience for Java. So, oh well, here we are. It's not even 20 years, it's nearly 30 years. In 2 years' time, it will be 30 years since Java first came out, and that's quite impressive. But we are where we are with primitives. Okay, so let's talk about future concurrency. Okay, vthreads, yay! I think vthreads are great. I think when I did my turnover and bump up my project version to 21, which I'll be doing in the next couple of weeks, I think we'll actually start to see some vthreads in production, which would be nice. But it's not the end of the story. There are two major pieces of Loom which follow on from vthreads. They build on vthreads as a building block, and they're called structured concurrency and scoped values. And I'm not going to talk about them more. If you follow that link, you will find an article which I wrote about them, which came out just this week. So what else? The point about slightly functional nature. I think Java is not that functional a language. It implements some idioms, but the collections are very concrete. They require the stream abstraction. You can't directly fit functional aspects onto collections because it just doesn't work. But the punchline, the sting in the tail of all of this is, does it matter? Does it matter that Java is not that functional? Does it matter that we can't retrofit things on perfectly? Not sure it does. Since Java 8, developers have loved lambdas, and we work around the occasional clunkiness of having to deal with streams and terminal operations and moving backwards from a lazy mode back into an eager mode, etc. And there are still some modest improvements to come. We have algebraic data types now. They came in 17. We have the starts of pattern matching. Would have been nice if it was a bit more complete in 21, but there we are. So there are more steps that can be taken. But I don't know that there is that much road left before we run out of things which can be done to Java to make it more functional. Okay, the JVM. Today's JVM is not a particularly natural fit for containers. People want small footprint microservices, and this is what leads to all this enhanced innovation that we've been talking about. So in things like frameworks like Quarkus and Graal, in OpenJDK itself, of course, Leiden, Valhalla and Panama for better fit to native code as well. But some of these are still quite a long way off. I don't know when people will actually start seeing Valhalla land in mainline. It just isn't clear to me. And so, finally, let's talk about the cloud. So, I've always liked this idea of what we build in software as being kind of like castles in the air. It's a city in the clouds, and it's the future. So one of the things which I think I said I would talk about earlier is my last topic, I think, is LLMs. Hands up if you're using GitHub Copilot or another LLM. Interesting. I've been using it for about 3 weeks now, and it gives modest gains, is my opinion. The sort of code that I used to write by going and bashing Stack Overflow and finding things and then cobbling it together in the IDE, it's quite good at. But the percentage of your time that you spend doing that type of work is going to vary depending on how senior you are. And generally speaking, the more senior a developer you are, the less time you spend doing that. And outside of that use case, it's really not very helpful. So will it make junior developers and intermediate developers more productive? Yes, it absolutely will. Is the speed boost worth having? Yes. Is it going to replace you? No. And so I just really treat it as almost like an enhanced IDE skill. So I would recommend that you check it out. It, of course, has a huge drawback that it's only tested on GitHub as a corpus. So modern Java and future Java, there's very little of that in GitHub. So it can't really advise you on that. And this is less of a problem for us because we're Java, so statically typed languages. It definitely hallucinates. It just makes stuff up. It makes up classes, it makes up enums. Now, in IntelliJ, that just doesn't matter because it immediately flags it as red and you go, what are you talking about? There's no enum state called that. And you fix it. JavaScript and Python programmers, I think, are going to have a bad time because I think this is going to be a very significant source of runtime bugs for them. And I don't know what to do about that. So yeah, I think that for programmers, LLMs and AI are interesting, but I don't think they're anything that we particularly need to be scared of. And finally, you could in fact ignore everything I've just said over the last 50 minutes, because whatever they tell you, it's still a people problem. It always has been, I think it always will be, And the biggest thing you need to understand is that this is a team sport, and your communication and your interpersonal skills are not soft skills. They are the essential skills. If you have those, you can learn the technical part. That's kind of the last piece of what it means to be well-grounded. And after 14 years, this community still absolutely rocks. I think it's extremely telling that the number of people in the community who have worked together and on projects or frameworks or open source projects or whatever, and are still somewhere between totally cordial colleagues and very good friends. That is a very large number, and it's not something I've seen in other technical communities. So the community's great, we should do this more, and we'll anticipate seeing Java 41 10 years' time. See you then. And as a final thing, I just wanted to give you 2 links. First of all, have a free book. The 8th edition of Java in a nutshell is free to download, courtesy of my employer, Red Hat. And my co-author, Jason Clark, has produced a very interesting report on the state of the Java ecosystem, which is derived not from developer surveys or self-reported information. It's derived from tens of millions of production JVMs. So if you want to know what versions of Java are really in use and how people are configuring their containers with real information, then it's a good read. Okay, folks, thank you very much.